Okay, this is, I'm going to project a body from a ground. There's a ball or a stone. It is projected with a speed u. Now, what will be the state of this? There's a ground. Okay, we'll separate. We'll just indicate. Okay, there's a ground. We'll mark it. Now, what is the path? Path is going to ascend. Then it will descend. Again it will ascend. Again it will descend. Like this continuously. If there is no loss of energy due to impact with the ground, the ball is going to oscillate. The ball is going to, in fact, will be oscillate. Okay, let me call this a ball itself. So here it will be. Again projected. Again it will retrace path. And this will be a better diagram. Yeah. Now after this, again the path will be. This is for our convenient. Actually, it has to retrace path. It will be very difficult to show. That's why we are bringing the situation like this. I'll keep this arrows. At least you're able to understand. It will be ascending. This will be descending. Again, this will be ascending, descending. With what speed we have projected, with the same speed u, it will strike and it will rebound with the same speed. Some other colors let me use. So what is the condition we have put at t equals 0? We have projected. What is the time here? U by g. After what time it will come here? 2u by g. I'll use different colors. It will be easy for you to notice things. So again, after what time it will be here? 3u by g. Here it will be 4u by g. 5u by g. 6u by g. Like this we can. Again, it will be 7u by g. This will be enough. So like this, the time of ascent, you have to add u by g. So total for the ball to move from the ground to ascend a height u by g. Okay, this is the maximum height. H max. Let's plot the graph of this VT graph, and I'm interested in the speed versus time graph, velocity versus time graph, and also the position versus time graph. I'm going to project it from a ground. Okay, this is the ground. I'll go for smaller one because I have to indicate all the parameters here. Marking, if I do properly, I'll get an exact shape. We'll do one thing. And spacing between the lines should be equal, so that we'll get exact shape of the curve. I'll try my level best to get a good graph. No, we will do one thing. Let it be. No, first velocity versus time graph. V bar and this is a time. So this will become, I projected with a velocity u. First is undergo retardation. So the curve will be this is what the curve. It was projected with a u at highest point minus u. What are this interval of time? U by g, 2u by g, 3u by g, 4u by g, 5u by g, 6u by g. The direction of motion will change, not the gravity here. That the interpretations, how the g will act. Will acceleration due to gravity will change? No. The direction of motion, in fact, varies. No. So therefore, this particular graph indicates here. You should not make this positive here. It's a velocity because after u by g, you see like a t equals 0. The velocity, like a here, the velocity is upward. After u by g, the direction of motion changed. But how the acceleration due to gravity will act vertically down only. So this is a retardation, this is acceleration. The curve should be off like this. Why they should have same slope? Because the direction of motion changes, not the acceleration due to gravity. Okay, let's plot the speed versus time graph. First, it will undergo retardation, then acceleration, then retardation, then acceleration, retardation, then acceleration. This is speed. Speed will just indicate v that one. So this is speed. Okay, this is what are the time? U by g, 2u by g, 3u by g, 4u by g, 5u by g, 6u by g. Okay, look at the speed versus time graph for a ball projected vertically up. And what is the basic necessary condition? So here a ball is projected vertically up with a speed u from ground at t equals 0. And it bounces up and down with no loss of energy. And let there be no loss of energy due to impact but practically there will be a loss of energy. It cannot rebound to same height. So just after impact, this u will be less than the velocity to strike the ground. So what is the practically how it will be? We're assuming no loss of energy, so therefore that H max will remain same. and let there be no loss of energy due to impact with the ground. So it will just bounce up and down. So the speed versus time graph will be of this nature. Now, what about the position? The position versus time graph. Position again, we have projected it with a speed u. So it will be like this. This is H max. And this is u by g, 2u by g. Okay, like this, the position versus time graph will be there. So what is this? This last quantity, I should call it as position. So this is what happens for the bouncing ball. If there is no loss of energy, the curves will be of this kind. Okay, similarly, one more graphical thing we'll discuss. For a body, for the ball released from certain height from the ground, and there won't be loss of energy due to impact. The other condition will bring it. So